Now in this section, we're going to talk specifically about linear equations and rational expressions. Again, of course, the linear equations we will be solving, and along with rational expressions, we will have rational equations as well, and we'll define them in just a minute. Well, starting off with a linear equation in one variable, which means it doesn't have an x and a y, it just has x, is an equation that can be written like this. ax plus b equals 0. A and b are both real numbers. A can't be 0 because then there would be no variable at all. So a has to be a non-zero number. So real simple examples would be 2x plus 3 equals 0. That is certainly a linear equation in one variable. And by the way, for the variable, I'm going to use x each time. We could take negative 1/2 x equals 0. Is that a linear equation in one variable? Well, sure it is. All we need to do is identify the a and the b. Well, a is the number that's multiplied by x. So a would be negative 1/2. And what would b be equal to? Well, b would just be a 0. Remember, b can be any real number. A can be any real number that's not 0. How about something like 3x equals 5? Well, sure, that's a linear equation in one variable. It's not written in this form, but we could write it in that form. Now, how would we identify what the a and the b are? Well, a is the 3, because it's multiplied by x. And if we subtracted 5 from both sides, we would get it exactly in this form. So this could be rewritten as 3x minus 5 equals 0. So yes, it is a linear equation in one variable. A would be 3, b would be negative 5. Let's look at one more simple example. How about just x equals negative 1? That, in fact, is a linear equation in one variable because it could be written x plus 1 equals 0. In this case, our a would be the number 1, the coefficient in front of the x, and then b would also be a 1. So that's linear equations in one variable. And now let's look at a vocabulary term we've seen before already. By substituting negative 5 in place of x in this linear equation, we obtain a true statement. Because 3 times negative 5 is negative 15, plus 15 gives us 0. So thus we say that negative 5 satisfies the equation, or we could say that negative 5 is a solution. And actually in this situation, negative 5 is the only solution, but frequently we'll have equations that have multiple solutions. All right? The number 3 is a definition. The set of all values that satisfy an equation is called not just a solution, but the solution set. It's the set of all of the solutions. So in our previous example, negative 5 was the only solution to this equation. So the solution set would consist of the set just containing negative 5. Now let's review. You've probably done this in almost all of your math classes. Let's find the solution set for this. And by the way, this is a linear equation in one variable. If we were to simplify it, we could, and actually we will, get it into a form that looks something like this. Maybe not exactly that, but we could write it in a form exactly like this. Okay, so let's find the solution set of this equation. So we're going to simplify each side and combine like terms on each side individually. So what I'm going to do is the distributive property there and the distributive property there. So that's for starters. So 2x minus 6 minus 17 equals 13. Now don't forget to multiply the negative 3 times x and the negative 3 times 2. Minus 3x minus 6. So, on the left-hand side, we get 2x minus 23, combining those two together. And that's equal to, let's combine these like terms, the 13 and the negative 6. 13 minus 6 is 7. So now we have done exactly what step 1 says. We simplified both sides and we combined the like terms. So now we collect all the variable terms on one side. That's like this term and this term both have x's in them. So by subtracting 3x from both sides, adding 3x to both sides would cancel it out here. Adding 3x would give me 5x minus 23 equals 7. And now I want to get the constant terms on the right-hand side, the numeric terms. So adding 23 to both sides would give us 5x equals 7 and 23 is 30. Now we almost have this in that form that we talked about earlier, ax plus b equals 0. If I subtracted 30 from both sides, I'd have a equal to 5, and the minus 30 would be the b, and we would have a 0 on the right-hand side. Okay, so we isolated the variable term on the left, and now we need to isolate the variable, x by itself. So what I'm going to do, since I underlined that, I'll do it on both sides and divide both sides by 5. And that gives us x all by itself on the left, and 30 over 5, or 30 divided by 5, is 6. And then you should always check the solution, which means take the value of x, which is 6, go back to the original equation, and maybe I will write it, since I don't have much room up here, I'll write it down here. If we were to replace x with 6, what would we have in parentheses right here? That'd be 6 minus 3. So I'm going to write down 2 times 3, because 6 minus 3 is 3, minus 17 equals 13 minus 3, I should say. And in parentheses, we have x plus 2. Well, x is a 6, so it would give me 6 plus 2 for 8. All we need to do is make sure that this is a true statement, and we'll know that this answer of x equals 6 is correct. So what does that give us? We get a 6 here, minus 17, equals 13 minus 3 times 8 is 24. 6 minus 17, what would that give us? Negative 11 equals 13 minus 24 also gives us negative 11. So this x equals 6 is the solution to this equation.